So our next unit is about right triangles, and the first thing that we're going to do is Pythagorean theorem. I know you've seen this before, so I'm just going to kind of refresh your memory. The first thing that you need to know is that Pythagorean theorem can only work for right triangle. And we know a right triangle, of course, has the 90-degree mark. So what does this help us do? Well, it's used to find the missing sides of a right triangle. Sides A and B are the legs of the triangle, and side C is called the hypotenuse. And my formula for any right triangle is a squared plus b squared equals c squared. And we're going to talk about why that is in a second. But let's go back up here real quick. A and B are called the legs. C is my hypotenuse. C is always opposite my right angle, and it is always the longest side of a triangle, okay? So that's a quick way to check your answer, is to think, okay, is my hypotenuse the longest side in this triangle? And if it is, well, then that is a good thing, because it needs to be. So here's how Pythagorean theorem came to be, okay? Pythagorean theorem says that if you have a triangle, let's say 3, 4, 5. So Pythagoras said, if you took the square of this side, so a square is the same length and width, so if this is 3 and this is 3, and I found the area is 9, and if you square the other leg, 4 times 4, and squared is 16. So he said, if you found the area of these, the squared area of these squares, that would equal the area inside C, which is 25. It means I'm adding them up. 16 and 9 is 25. So you square this leg, and you square this leg, and you add the areas together, and that gives you the area of this square. But we just want to find the side. So if the area is 25, what do the length and width need to be to make this statement true? It needs to be 5. So this hypotenuse is 5. So think about that when I do this, when I show you this. So let's say this is 6 and this is 8. So let's do it again. If I square, and remember A and B are the legs, if I square a leg, 6 squared, and I found it was 36, and I square this leg, so b squared is 8 squared, and it's 64, so I get 64. And then I add these together, it's going to give me the area of c squared. But I don't want the area, I want the square root. So I get x squared equals 100 if I'm looking for x squared. So what do I have to do? I take the square root. So x equals square root of 100, which is 10. So that's how he's getting the formula when we go back up here. And I look, for any right triangle, he squared this leg, he squared this leg, he added them together, and then he got the area of that other square, the biggest square, the hypotenuse. So that's the formula that helps me and allows me to solve for right triangles. So on this one, I know that 8 squared plus 13 squared equals the whole area of this. So now in my calculator, I'm going to do 64 plus 169 equals x squared. And when you add those together, you get x squared equals 233. I don't care about the area, I care about the side. So I'm going to take the square root of 233, and I get x equals 15.26. And that would be the length of the leg, of the hypotenuse. Sorry, length of the hypotenuse. All right, let's do another one. And again, you do not have to write out exactly what I did there. Now, look at this one. Here are my legs. So the square of this leg plus the square of this leg equals the square of the hypotenuse. And now I just solve for x. X squared plus 49 equals 81. Subtract 49 on both sides, and I get x squared equals 32. And then I need the square root because I just want the side, not the area. So x equals the square root of 32, which is 5.66. Okay, so that's how you find it there. If I go down and look at number 5, so for this one, I want the height of this triangle. So if the whole length is 22, I know this length is 11. And now I'm not able to write on the board anymore. So this length is 11. Interesting. So now I would have 11 squared plus x squared equals 24 squared because my hypotenuse is 24. So now I get 121 plus x squared equals 24 squared, which is 576. So I'm going to subtract 121 from both sides, and I get x squared equals 455. 455. And then when I take the square root of 455, I get my x value is 21.3. So this height is 21.3. So that's just a quick refresher on Pythagorean theorem. If you are struggling, come see me. Let me see if I see anything that's crazy. Well, look at number 9. So if you know that this length is 26, right here, I know that the whole length is 40. So 40 minus 26 is 14, and then these are the same because it's an isosceles trapezoid. So this is going to be a length of 7, and this is going to be a length of 7. So 7 plus 7 plus 26 is the whole length. I know that this hypotenuse is 20, so if I want to find the height, I'm just going to use x squared plus 7 squared equals 20 squared, and I get 400. So I get x squared equals 351, and then I take the square root of that, and I get x, the height is 18.73. So that would be the height. Now, real quick, I'm sorry, I try to cut it short, but I can't do that. Let's look at how we use the application here. So on number 11, let's just do that one. You've got to draw a picture. So Kurt is building a rectangular deck. If the dimensions of the deck are 10 feet by 23 feet, what is the length of the diagonal? So here, you would just draw a picture and then find the hypotenuse. So 10 squared plus 23 squared equals x squared. So 100 plus 23 squared is 529 equals x squared. So 629 equals x squared. And now to find the diagonal, I just take the square root of 629, and I get x is going to be 25.08 feet. Make sure you label the feet. So on these, just make sure on the applications that you're drawing a picture and that your picture matches the word problem. And come see me if you're struggling.